Hey everybody, welcome to the AI Data Quant video series. Uh, my name's Steve Cannon. We're talking today about data pipelines. The reason we're talking about data pipelines in AI Data Quant is because both AI and Quant rely on real-time updates so that they can adjust their models and so that they can make predictions with existing models. This turns out to be kind of important. One, because getting those updates is urgent, and so and then also because of errors, right? So for two reasons, data pipelines are important. One is you want to design them so you can get the data quickly, and two, you want to prevent data errors, erroneous data from arriving and polluting your models and polluting your predictions, right? So data pipelines become very important, kind of both as an engineering topic and as a business topic of how do you make them work. I don't really love the term operations because it's kind of more, it's like modeling / operations. So building a model is not done when you deliver the parameters and you do some back tests, right? The model is a live thing and it's used to make predictions, and as a modeler you're responsible for those predictions and those updated predictions, and you better pay attention to that. You better focus on that. I mean, modelers are entirely engaged with data. I mean, good modelers are so focused on data that you would almost think that the math isn't important. It is, but if you saw what they did and how they talk, it's entirely focused on data, and they rarely trust data preparation to the specialized data people because for very good reasons. These data pipelines are kind of, so from an engineering standpoint, the more important thing to remember is well, there are various speeds and various update frequencies, and there are all kinds of different things that you should be focused on if you're thinking about engineering them. But ultimately, I'm going to be a little bit more focused on debugging, and I want to think about debugging in two ways. One is kind of what are the tools that you use and what are the procedures that you use to debug, and then who are the people that you need to debug these things. So data pipelines and data teams, I guess, is the topic here. So right, so let me kind of, maybe you already know in your business why debugging data and debugging data pipelines is so complex, but let me just go through it quickly. I made some notes. So it's urgent, right? So typically it may be a 24-hour cycle or maybe sub-millisecond cycle, but even whatever it is, it's urgent. There's those predictions. If you're running a prediction, you want it to there's a reason you wanted it now, and you want it to be updated with the current data. So it's urgent, and sometimes the tricky part happens with data where there's missing data or the data source goes down and it's from a vendor and you can't fix it, right? Or there's just missing data, or there's bad data that you're getting and you cannot fix it. So you have to know what to do. So debugging includes doing the best thing possible with that situation, and it's complex, right? So it's also the case that just for very good reasons, and most data processing and data updates are done in multiple different steps. So when you see, let's say your errors can happen in two ways, right? So one, you check the data or you check downstream results of the data and it doesn't look right. If nobody has a magic wand to wave to see if data is right or not, so you put in place various checks to kind of see if you think it looks broken, right? You can certainly see if it's missing, but other things that are kind of like, it's a guess. Like ideally, you wouldn't know what to expect from data, so how would you know that it's wrong, right? It's supposed to contain new information. So on a theoretical level, you do not know whether that data is broken or not, but you can check to see whether it's so there are two kinds of, there's those kinds of things where your check fails, or there's a kind of thing where but in either, let me skip that. So in either case, the data, you're going to get kind of, it's going to happen at one step in the process, and so you'll get a stack trace in that second, but you won't get the whole stack trace. You're going to have to move up and down the pipeline to figure it out, right? So that is tricky, and if you have not engineered your system to be able to do that efficiently, you are going to be up a creek. That is not a good situation. So the most important thing with these tools is not the speed, but their ability to be inspected and understood and fixed, right? So then you have to kind of decide, upstream or downstream. Move upstream until you fixed it, and then when say processing has already moved on, how do you then push that downstream back and fix the downstream effects that have gone into effect? Or how do you, so there's both upstream and downstream stuff. And then another complicated piece is unregistered uses of the data. So things that the data is being used for that you didn't know, and so when you fix it, you don't notify that downstream user, that downstream process of the change, and they don't fix it, and then you have problems, right? So the other thing is that data errors can be very high impact, right? So from a few $1,000,000 to hundreds of millions of dollars. There are, and then that the worst part is that data errors and processing errors in these predictions can go unfound. So sometimes it can be a matter of years before you discover them, in which case that they've compounded, which is bad news. So that's why this is hard. That's why engineering it is hard, and it's mostly engineering is very easy if you've never if you don't care about the people who are running it or the outcomes, but very hard if you do care about the outcomes. And then the people you need to do it, so the data team, basically you want a combination of operators, coders, and quants for everybody who's doing this job. So basically, I kind of think of it as a quant. The best possible case is a quant who already knows how to code, right? So quants know how to code already, but who's maybe a better coder than most quants, and maybe doesn't require quite all the super high-end. Not every personality not every aspect of the personality that's required to be a good quant, but should have the mental capacity of a quant. And then finally, you really need somebody who's focused on process engineering or reliability engineering and how to engineer processes. These are very specific kinds of people. The key is, okay, they have to have the skills. They have to have the intelligence. So a lot of the skills are similar to being a quant, but also understanding how to engineer reliable processes. And then they need to have the interest. That's the real hard part. They need to be interested in creating reliable processes. And you need to set up these teams. Ideally, they need to be able to, if you're running them kind of on max, you will get a data process that decays over time and does not give you good results. So you need to be running them on like 50% because you want the data team to do the temporary solution and then go back and do the permanent solution as soon as possible and be interested in that. All right, that's I think that's what I wanted to cover today, and we'll come back with some more kind of details and dig into this. Thanks.